Snowflake has been designed. At the back end, what are the layers has been available in Snowflake, we will just see today. And this is the most important topic. Like, we need to understand theoretically how the Snowflake is working. This is nothing but like Snowflake process, how it is being storing, how it is calculating the data or playing the data, what are the layers we do require. We need to understand. This is the most important topic, and you will get most of the interview questions from here only. So you need not only saying like these are the layers, so we need to explain what each layer works does, and costing things also we need to understand. So first of all, we'll start with the introduction. So Snowflake is a analytical data warehouse. So cloud analytical data warehouse, which is provided as software as a service. Yes. So we know Snowflake is already a cloud analytical data warehouse, which is hosted in the cloud, not on the on-premises. So it's a cloud analytical. It stores the data. Historical data also stores, which uses for decision making, forecasting, so demand, purchasing, everything it will with this historical data. And end of the day, we are storing different aspects of the information of an organization in one particular place. Here we are storing the data, so that's the reason it is called as a data warehouse. So cloud analytical data warehouse, which is provided as a software as a service. So as I mentioned, we will use Snowflake as through browser, just a browser, no installation, no configuration, no maintenance, nothing. So a readily built software is provided as a service, so we will call it as a SaaS. Snowflake runs completely on the cloud infrastructure only, not on on-premises. So as of today, Snowflake can be hosted or can run in AWS, Microsoft Azure, and GCP, Google Cloud Platform. So these are the three cloud platforms which Snowflake runs. Okay, so we are saying Snowflake is a cloud analytical data warehouse. So analytical means it contains historical information. So that means Snowflake will only do storage of the data? No, it can store the data. Data storage can be done. Data processing. Let's say you got the raw data and you have to transform the data. You want to apply some functions, then you can do data processing can be done, and it provides analytical solutions. So with the historical information, we can decide, okay, whether we have to go with this product or any updations needs to be done or any price modification needs to be done. So that type of analytical solutions we can do. And Snowflake is faster because we have like a large set of compute resources. We can have increase and decrease based on the traffic, easier to use. So because it's a communication language is SQL, so whoever knew SQL, if we just have the idea about Snowflake features, then they can easily work on the Snowflake, and far more flexible than traditional data warehouse offerings. So whatever the new features which are available in the Snowflake, like time travel, zero copy cloning, streams, secure views, materialized views, with the help of these, like it is like flexible than the traditional data warehouses. So this is the introduction, like how Snowflake is there. Any doubts here? Guys, please let me know if I'm going fast. Stop me there and ask. Okay, I'll make it up. Here, now comes to the Snowflake architecture. So here we have three layers of architecture. Snowflake is a three-layered architecture from top to bottom or bottom to top, anything. Like I will start with the database storage. The first layer is called as database storage layer. The next layer is query processing layer, which is also called as a compute layer. So this is the second layer. And the third layer is cloud services layer. So we will call cloud services layer as a brain of Snowflake. So the complete maintenance will be done at the cloud services layer. So it will be called as a brain of the Snowflake. So here we need to understand, as I am saying, database storage, query processing, cloud services, three different layers, and these three are not dependent with each other. So they are independent with each other. Whatever the activities done at the database storage layer will not be impacted for the query processing layer, and vice versa. And also with the cloud services, whatever it is handling will not impact the query processing layer or database storage layer, and vice versa. So these are purely independent with their activities, works, and also the casting part also, it is different. So we will see how it works, like what exactly this each layer will do, we'll see. So this is the like a full picture of this. Like in the database storage, we will maintain all the data in the form of tables. Again, in the query processing layer, if you want to perform any DML or TQL operations, let's say you want to retrieve the data from the table, or you want to update the records in the table, you want to insert the data into the table, manipulation of the data is happening, then this layer comes into the picture, query processing layer. So here we will create virtual warehouses which provides compute resources. So we can create n number of virtual warehouses here. And the cloud services layer, like it will handle, apart from the storage and compute, it will handle all authentication related activities, metadata management, optimization, security checks, everything here it will be handled in the cloud services layer. Now we'll just see in detail about these layers. So before entering into the Snowflake architecture, in the market, if any new technology will come into the market, then we have to say, we have to compare that particular architecture with two benchmark things. So that is shared disk architecture and shared nothing architecture. So these are the generic architecture types, and we need to say our, let's say Snowflake or any other data warehouse, which the data warehouse fits into either shared disk architecture or shared nothing architecture, or both, we have to justify. So here these are the two benchmark architecture types, shared disk and shared nothing. How our Snowflake fits into shared disk or shared nothing or both, we will see here. So before entering into that, like we need to understand what is shared disk architecture and what is shared nothing architecture. Then only we can justify, okay, Snowflake is working like this. So first of all, we'll see shared disk architecture. If we just see the picture here, whatever the disk storages, every architecture have the same model. Disk storage will be there and compute resources will be there. So, but what is the interaction, what is the level of dependency will be differing from architecture to architecture, Snowflake or Teradata, Oracle. So it differs from different technology data warehouses. So here, shared disk architecture means one storage layer will be available. In this storage layer, all the data will be accessible to all the clusters, which is nothing but compute resources. So we will, in the compute resources, we will have CPU, memory, temporary storage, RAM, all these will be available. So any, the storage layer is accessible to all the compute resources. Let's say we have 10 compute resources. Even 10 compute resources can access the data from any of the disk storage, because it's distributed, like whatever the data available in the disk storage one is the same data will be available in the disk storage 2. Again, the same will be available in the disk storage 3. So if this is the pattern, then any compute resources can access any disk storage data, because complete data is available or replicated in all the disk storages. So that's the reason any compute resources can access any disk storage. So what is the use of it? Like the same information, same information we are replicating to the other disk storages. So why we will do, in which scenario we will do. So let's say we are in an on-premises data warehouse, and we have the team in Hyderabad, Bangalore, and Chennai. So in these three places, our team is working. We need compute resources for playing the data. Now, let's say in Chennai, we got floods. So at that time, some of the offices, like where on-premises has been set up, some of the offices has been flooded, and all the disks, everything got shut down. It's not in a working condition. Even at that time also, the people happily used the data, played with the data of Hyderabad and Bangalore team. How it is possible? Because of this kind of architecture. So even though the Chennai disk storage has been shut down, we still have the Hyderabad and Bangalore storages. And here the concept is same data is available even in the Bangalore and Hyderabad disk storages. So any compute resource, any person can access the data either from Hyderabad or Bangalore, even though Chennai has been shut down. So at that situations, it will be very helpful for us. So if we encounter, we foresee that kind of issues, then we can use this disk share architecture. So one storage layer accessible to all cluster nodes. So cluster node is nothing but compute resources. Multiple cluster nodes having CPU and memory but no data storage. So here every compute resource have like their own CPU and memory, but the disk storage needs to be used commonly wherever from the database storage layer. Individually, it doesn't have the disk storage. So it can access storage 1, storage 2, storage 3, anything it can be accessed. So here, what are the advantages? So whatever we have discussed, so one disk storage failed, we can recover the data or retrieve the data by not failing the operations. We can use the data without any issue from the other disk storages. Disadvantage, if we are replicating the complete data into multiple disk storages, then the storage cost will be doubled and tripled. So here, let's say if we are maintaining 3 disk storages, we have to pay for the same data, we have to pay 3 times of cost. So this is the only majorly I'm saying, we are not completely discussing about this shared disk and nothing. So here, this is the concept, shared disk architecture means. Now we'll just come to the shared nothing architecture. So here, the name itself saying like their shared disk storage we are sharing. Here we are not sharing anything, shared nothing architecture. So if you see the diagram, so every compute resources is having their own disk storage. That means it's not at all distributed. So disk storage 1 will be accessed only by the compute resources 1 or cluster node 1. Disk storage 2 can be accessible only by the cluster node 2. It cannot be, let's say it is busy, I mean cluster disk storage 1 is busy, so the can cluster node 1 access the disk storage 2? No, it cannot do that operations, because these are independent with each other. It has to accept the data only from the disk storage 1, and it cannot accept the data from any other disk storages. So this is the concept of shared nothing architecture. So here there won't be any sharing will be happen, shared nothing architecture. So the advantages comes like the cost wise, it will be very less when compared to the shared disk architecture. And the disadvantages, like we cannot recover the data if the same situation flooding happens. We cannot recover the data because these are independent with each other. So at that time, the recovery, I am not saying it is impossible. It takes time, and up to that time we cannot access that part of data. So it will be in a downtime or shutdown time. So we cannot access the data. The operations will get failed. So this is the concept of shared nothing architecture. Now, how our Snowflake fits into this particular shared disk or shared nothing architecture? So Snowflake is a hybrid. It is a combination of shared disk architecture and shared nothing architecture. So will it be like that? Any architecture will accept both the will be fit into shared disk and shared nothing? Yes, it is there. So our Snowflake also it's a hybrid of shared disk and shared nothing architecture. We will just see how it works, which layer fits into shared disk and which layer fits into shared nothing architecture. We'll see. So first of all, we'll start with the layers. So the first layer is database storage layer. So the name itself, with the name itself, we can understand whatever the data we are storing in the form of rows and columns in tables under databases, that will be stored in this particular storage layer. But as it is, like for our namesake, it will be a table. So if we want to retrieve the data, we need to say select star from table. But at the backend, it will be stored in a different format in the database storage layer. So if we just see the point, after data is loaded into Snowflake, it reorganizes the data into its internal optimized, compressed and columnar format. So when I load the data into the table, let's say I'm loading 100 records into the table. Once all the data is loaded into the table, so in the database layer, it will not store in the same rows and columns format. It will store in the columnar format. So first, what it will do, once the data is loaded, it reorganizes the data. So what does it reorganizes the data? See, if we have like 100 records at one place, it is tough to retrieve, to generate algorithms for the retrieval process. So that's the reason out of these 100 records, based on the volume, so it has some volume like 50 MB to 500 MB. So between this range, it will create one partition and reorganizes. Out of these 100 records, it will calculate how many partitions it will become, micro partitions, how many it will become. So it will just reorganizes the data in its internal optimized. So into its internal optimized means, so it will generate algorithms and compression algorithms based on the data, and it will remake the data in the form of partitions. So again, this data will be stored in the columnar format. So now you might get confused, like what is this compression algorithms, everything. But we have a topic called micro partitions. A class will be there. So at the time, you will understand what is columnar format, what is compression, everything. So as of now, once the data is loaded into the table, at the backend in the database storage layer, it will not store as it is 100 records. It reorganizes the data based on the algorithms for optimization and also for compression. Then this data again stores in the form of partitions in a columnar format, not in a row level format. So these will happen at the backend once you load the data, and this concept we will call this, whatever storing at the backend, we will call the name as a micro partitions. So in a very less small size, it will divide and maintain the data at the backend. So will can we see all these concepts? So whatever the optimization algorithms or compression algorithms and columnar format, what happening at the backend? So let's say whatever I am saying, micro partitions, can we see all these things? No, we cannot see all these things. This will happen at the backend. So we don't have permissions to see like which record entered into which micro partition, that we cannot see at all. Only we can see for a table how many micro partitions are available, but we cannot see like what are the algorithms generated, nothing, no access for these mechanisms. Not only for me, even for a trial account, for real accounts, subscribed accounts also, we don't have any permissions. Only you can see the table and the data in the table in the form of rows and columns. These all happens at the back end. So it manages all aspects of the data stored. The organization, that means like the reorganizing, file size, structure, compression, metadata, and statistics. So once the data is loaded, it generates micro partitions, like indirectly to say, it generates micro partitions. So the micro partitions will be generated based on the factors. It reorganizes the data, compresses the data, it captures the metadata and stats of each micro partition. So in each micro partition, you will have how many records, what are the distinct records, what are the null records, for each column, what is the minimum and maximum. So this type of stats also will be available. So do we need to do anything like from our end to capture all these things or to manage all these things? Nothing. At the back end, once your part is just loading the data into the table, the rest of the work, whatever generating micro partitions based on the algorithms, everything Snowflake will be taken care at the back end. No visibility here. So data objects are not visible directly to the customers, but it can be accessed through SQL query operations. So retrieval of the data you want to do, then you can use the SQL command and get the data here. So in this particular layer, only work is the data storing in the form of micro partitions. That means reorganizing compression in a columnar format, which is nothing but micro partition. So in this particular database storage layer, you will have the data in the form of micro partitions. So micro partitions, we will have a separate class. I'll explain there how exactly it will store the data, how it generates the micro partitions. We'll see there. So this is about database storage layer. So any doubts here? No, yes? Okay. Now we'll just move to the compute layer or query processing layer, the middle layer we will call it as. So now the data has been stored in the database storage layer. Now, let's say I want to perform any DML operation. Let's say I want to delete one record from the table. What do I require? So I need compute resources. Just for storing purpose, we don't require compute resources. Okay, for doing any DML operations, let's say you want to insert the record, you need compute resources. So these compute resources are RAM, CPU, memory. So without this, you cannot perform uh, DML operations and DQL operations. So you cannot manipulate the data. So what does in this layer available? So we will have compute resources will be available in this particular layer. So first of all, what is compute resources? Why do we require? So we'll just talk in a general terminology. When we are buying a laptop, what we will check, like we will check the storage part, hard disk, how much it is there. So I need this 1 TB or 500 GB. So these kind of things we will check the storage thing, how much we can store. Then we will also check one more thing, the compute power, which is nothing but what is the CPU rate, what is the RAM we are having. So why we do require this CPU and RAM? Because to perform any operation, let's say I want to navigate, I want to open a file, then I in the Excel I want to fill some data. So how speed it is doing, and parallelly you want to watch a movie while doing this Excel activity, and you want to play a game at the back end. So all these uses compute power, which is nothing but CPU and RAM. So let's say your CPU and RAM is very low. The configuration is very low. What happens? For each activity, opening an Excel itself, it takes lots of time. And again, you want to fill, you want to save, then it is taking more and more time. So if you are doing this activity parallelly by watching the movie, then it will become very slow when we are doing parallel activities, because the compute power has been distributed for the movie and also for the Excel activity. So at that time we'll feel uncomfortable. So if the CPU rate is compute power is high, then you can do parallelly both the things. Like you can work on the Excel activity fastly, and you can do watch your movie also very comfortably, no issue. So these all, like whatever the operations after storing the things you want to do, that will depend on the compute power. So here also the same thing. We just dumped the data into the database storage layer. You want to retrieve the data, or you want to delete the data, you want to insert the data, you want to update the data. at that time you do require compute power. So here the compute power again same CPU, RAM, temporary memory. So these all three combination we will say it as a compute resources. So for Snowflake also we do require compute resources. That will be available in the query processing layer, which is nothing but compute layer. So what exactly will be available in this compute layer? So we will have virtual warehouses. So now I am naming compute resources, compute resources. So for the set of compute resources, Snowflake has given a name called virtual warehouse. So virtual warehouse consists of compute resources. So again, this virtual warehouse, we have a separate class. The next class will be the same virtual warehouse. So here, according to your requirement, according to your traffic, according to your demand, you can set like which type of virtual warehouse you do require, single cluster warehouse or multi-cluster warehouse, or what is the traffic condition. Is there a stable traffic? Then we need to use one type of policy. If there is a fluctuation traffic, then we have to go for the other policies. Modes are there. So we need to discuss like when you are creating a virtual warehouse, like which is nothing but setting up of the compute resources, then we have to decide like what is your work area requirement, what type of requirement is there. So here we will create like virtual warehouses in this query processing layer. Now compute layer is different from storage layer. This point I already mentioned. All the three layers are independent with each other. They are not at all dependent based on the work they are doing and also the costing also. Still, we know like in the database storage layer, only it will store the data. Here in the compute layer, it will process the data with the help of compute resources. So that's the reason it is different from storage layer. So here in the compute layer, we need to create virtual warehouses. So we can create n number of virtual warehouses according to your usage. So when a query is executed, it retrieves the data from the database storage layer. So let's say I am running select star from table. What happens? It needs compute resources to travel via compute layer to storage layer, database storage layer. So with the help of the compute layer, it goes to the database storage layer and bring the data to the onto the screen. So it requires compute resources. Each virtual warehouse is a massive parallel progressive compute cluster having multiple cluster nodes. So again, these virtual warehouses can be a single clustered warehouse, multi-clustered warehouse. Let's say your data is very less and traffic also very less, then we can go for the single cluster warehouse. And if it is like more traffic and fluctuation is there or stability is there, you need to have like a multiple clusters, then we will go for the multi-cluster warehouses. So we will discuss in tomorrow's class about this virtual warehouses, how to create everything we'll see. Each virtual warehouse is an independent compute cluster that does not share compute resources with other virtual warehouses. So let's say we have two virtual warehouses in our project. Now what happens? The first virtual warehouse is very busy with the activities it is having. So virtual warehouse 2 is free, somewhat free. So now can I use the compute resources from the virtual warehouse 2? No, it is not possible. It is independent with each other. So here in the compute layer, n number of virtual warehouses we can create, but those are not dependent with each other. So whatever the compute resources provided for you, you have to take. And the second, it cannot share, it cannot distribute the compute resources. So here independent with each other. As there is no dependency between each virtual warehouses, there won't be any impact on the performance of the other virtual warehouse. So first warehouse is busy. So whatever the second warehouse is doing, it will not impact any performance. Even the first one is busy or shut down, it will not impact because here it is independent with each other. So this particular layer mainly consists of virtual warehouses, which is nothing but compute resources. These compute resources are used for DML and DQL operations. So whenever you are performing that, you do require virtual warehouse mandatorily. Without that, you cannot do your processing. So here, any doubts? I have a doubt. So why we need to create multiple virtual warehouses? I'm saying virtual warehouse one, two, many. We can create n number of. So what is the use of these many virtual warehouses? So it's required in the organizations.
It depends on the, I think it depends on the size of data you have,
Yeah. So
and
uh,
whether it is current data or historical data.
no, it's not like that. Um, so I'll just give an example here. So let's say in our organization, we are having a Snowflake team. And here, let's say Snowflake team again, not only Snowflake, complete team is segregated as development team, support team, and testing team. So these are the three teams which are available. Now, let's say for Snowflake development team, they needs to use the complete data and understand the data, analyze the data, play with the data, right? So they need high compute power. Let's say if it is testing team. So for testing team, we will give the test scenarios, we will give the queries. So for them, no need to understand complete picture of the data, no need to play with the data. So they do require some low set of compute resources. Not high power is not required, low set of compute resources also sufficient for them. And whatever the traffic expected with the development team will not be expected with the testing team, because the testing team will not use complete data, historical data, and it's not their daily routine to do the development activities. Once the development activity is completed, it will go to the testing team. So that is the part. And production support. So production support also, it will run, the jobs will run on a daily basis or a weekly basis. Some on frequency it will run. Now the production support also needs somewhat compute powers like than the testing team, but not exactly with the development team. So a medium set of compute resources will work. So if I create one compute resources, which is nothing but one virtual warehouse with high, like a, it is in the form of t-shirt sizes. Let's say I have created with L size. Now what happens when we are creating from extra small to small, small to medium? What happens? The cost also gets doubled. So when I have created for high compute resources L size, and the testing team uses the same compute resources, what happens? The traffic will be heavy because development and testing both will be using. That is the first point. And the second point is they doesn't require that much high compute power. They, if they're having extra small also, it will be sufficient. So instead of that, why we need to pay double charges, more charges? So it's not required. So that's the reason for development team, I'll create one compute set, which is nothing but virtual warehouse with L size, high compute power. And for testing team, I'll just create one virtual warehouse with the extra small. So the cost also differs, and they will not impact the development team. Like they will not use the compute resources of development team. So the traffic will be there, queuing will be there. So that will not be there. Again, for the production support, medium set of compute resources are sufficient. So I'll create one more virtual warehouse with the medium size. So this, in this manner, like, not, this is not exactly only one example. It depends like what type of data you are getting. Based on that, you can create your virtual warehouses. We'll move to the cloud services layer. So this cloud services layer will be the work-wise, it exactly opposite to the database storage layer and query processing layer. So in the database storage layer, it deals with the data, only storage will happen. In the compute layer, again, it deals with the data, but it will be like processing of the data, manipulation of the data. So these two are completely related to the data only. But now cloud services layer, if everyone does the work related to data, and who will do the other activities? So the cloud services layer will do the other activities. So what are the other activities available? So authentication. So when we are connecting to Snowflake through URL, it has to, someone has to validate, right, whether this particular user is the right user or not. password is correct or not. So that type of authentication this particular cloud services layer will do. Not only the user login, the object also. Let's say one object is there, table is there. Let's say I don't have permission to that table. So at that time also it has to validate this particular user is using this role, whether this role is having select privilege or not, insert privilege or not. So that type of authentication also it will handle. Security related things also it will handle. Metadata management. So we have an information schema in Snowflake, which is maintained by Snowflake only. Here, in the information schema, what are the things available about each object? You will have the metadata. So the metadata in the sense, like when it has been created, who has been created, what are the policies available. Let's say if it is a table, what type of table it is, any constraints are there. So this type of metadata management will be handled by the cloud services layer. And also like how many records are there in each table, in each micro partition. So that type of information also it will handle. And query optimization, so that I will discuss now. So the query optimizer also will be handled. So few examples I will explain with the scenario wise how the cloud services layer is working. So let's say the same example, I have picked one URL, Snowflake URL, and I have placed in the browser. So then I have just clicked on that. So for that URL, who will be the user? Already Snowflake knew. So the Lahari is the user. So when I enter the username and the password, first what it will do, it will validate whether for this URL, Lahari is the right user or not. Okay, if the Lahari is the right user, then it will go for the next validation, whether the password is correct or not. So that validation also succeeds, it enters into my Snowflake space. So if any of the activities fails, it will throw error saying like invalid username or password. Some error, it will notifies us like you are not authorized. So this type of check or authentication security related works will be done by the cloud services layer. And the second example is, let's say I have submitted one query, select star from table. So for us, just it's a query, select star from table, immediately with within fraction of seconds, you will get the data also on the screen. But in between this fraction of seconds, some process has been happened. So what is that process? We will see. So let's say I have submitted a query, and who will get this query first according to the layers, database storage layer, compute layer, or cloud services layer. So it will get, I mean, this query will go to the cloud services layer first, not to the database, not to the compute layer. It will go to the cloud services layer first. So in this cloud services layer, few validations, few checks will happen, and then it will direct whether it has to go to the cloud compute layer or to the database storage layer, or both. So it will decide. So what are the checks it will do here in the cloud services layer after submitting the query? So first it will check whether this query is syntactically correct or not. So syntactically correct or not in the sense, you query is select star from table. Let's say you say select star table instead of from, you have from keyword you have missed, then it is syntactically incorrect. So first check is whether this query is syntactically correct or not. It will check. Okay, let's say if it is not correct, it will throw error saying SQL compilation error, something is missing or something is unexpected. It will throw error. Next, the second, let's say the first validation is succeeded, syntactically correct. Then it will go to the second validation, that is object is available or not. Whatever select star from table, whatever the table I am referring, the table is available in that particular schema or database or in the Snowflake account is there or not, it will validate. If it is available, then it will enter into the next validation. If it is not available, then it will throw error saying SQL compilation error, object does not exist. So this error we will see. Let's say The second validation also it has been passed. Then third validation. So third validation is on that particular object, whether this particular user and role have permissions or not. So I have logged in with sysadmin, Lahari user. For this user and role combination on that particular table, select access is there or not, it will validate. If it is there, then it will enter into the next validation. If it is not there, then it will throw error saying SQL compilation error, insufficient privileges. So it will throw error to us. So these are the validations, major validations it will do for any type of query, not only for select query. If you write delete query, insert query, create query, any query, first it will be picked by the cloud services layer and it will do all these validations. Once these validations are passed, then it will enter into the next validations. That is whether this query, whatever the user has been submitted, that query output is still available in the cloud services layer. So cloud services layer will hold the cache. So this cache is a separate topic for us. So just as of now, remember, cache means a temporary place where the results were stored for some period of time. So again, we have different types of cache: metadata, result cache, query processing cache. So we will discuss in detail about that in the later classes. But now remember the temporary place. The temporary place will be available in the cloud services layer. So if that particular query data is already available in the cache, then it will give the data from the cloud services layer only. It will not go to the compute layer and to the uh, database storage layer. Let's say the data is not available in the cloud services layer. Now it will identify what type of query it is. So is it a DML query or DQL query or DDL query? So for DDL queries, it doesn't require compute resources. It can directly send to the database storage. It can directly execute through cloud services layer only. Create, alter, drop, truncate, it doesn't require any compute resources. Let's say this is the select star from table, which is nothing but DQL query. So it needs compute resources. So that's the reason this query will be sent to the compute layer by cloud services layer, and it will say, okay, this is the DQL query and we do require compute resources to bring the data from the database storage layer. So now the compute layer, query processing layer will allot some compute resources. With the help of compute resources, it will travel to the database storage layer, and from the database storage layer, it will pick whatever the data it is required. Again, it will travel via compute layer to the cloud services layer, and cloud once the data is available in the cloud services layer, it will be visible to us on the screen. So these are the steps happens whenever you run a query. Cloud services layer. So this all process I will show in detail at the cache class, because we need to understand at each cache how it works, how we have to see everything. I'll explain in detail there also. But let's understand what is the importance of cloud services layer. I have told this example. Don't worry, it's too heavy now to understand this flow. It's fine, but just understand, whenever we submit a query, it will be accepted by the cloud services layer and do all validation and sends the query for whichever area it is suitable. So this particular work will be done by the cloud services layer. And metadata. Sorry, I'm not sure where it has disconnected. The cloud services layer examples, are you able to hear completely? Sorry, can someone please confirm where we have left?
Yeah, please
Yeah,
explain example.
yeah.
All
Third point, metadata requirement.
okay. Yeah, thank you. Yeah. So the cloud services layer will be maintaining in the cloud services layer. about each table micro partitions, how many micro partitions are there, what is the count in record count in each micro partition, minimum and maximum values, distinct values, null values. All this information will be maintained in the cloud services layer. So this type of information will be helpful for optimizing a query. So in a way, say we will say the cloud services layer will hold all this metadata which is used to optimize the query. So here the cloud services layer will handle all these type of activities irrespective of the data manipulation or data storage. These type of activities will be handled by the cloud services layer. So any doubts here in the cloud services layer? Okay. Now I have a doubt saying already I have told something shared disk and shared nothing architecture. But when I am doing explaining about the layers of the architecture, I haven't told like whether Snowflake is a shared disk architecture or shared nothing architecture. But I have confirmed it's a hybrid of both the shared disk and shared nothing architecture. So how it is both the shared disk and shared nothing architecture. So we'll just go here. So first of all, our database storage layer acts as a shared disk architecture. So here, once disk storage, I mean, the data will be available in a disk storage, which is accessible by multiple warehouses. Let's say development team, testing team, and support team warehouses, virtual warehouses are there. So all these three warehouses, let's say the users are accessing same table, like a employee table. The developer also accessing select star from employee, testing people also accessing select star from employee. So now both the virtual warehouses or both the compute resources are accessing single data warehouse or a common database storage. So that's the reason the database storage layer will be acting as a shared disk architecture. It is sharing the compute resources with all the virtual warehouses. So there is no problem in using like only development team, virtual warehouse, compute resources needs to use the data available in the database storage. It's nothing like that. Any virtual warehouse who are accessible can access the data from the database storage layer. Now, the query processing layer will fit in the shared nothing architecture. So the database storage layer will fit in the shared disk architecture. Here the query processing layer will act as a shared nothing architecture. Why shared nothing architecture? Here we can create n number of virtual warehouses, but the compute resources are not shared between each other. So whatever the compute resources available with the development team, that will not be shared with the testing or supporting and vice versa. So query processing layer will acts as a shared nothing architecture. So that's the reason Snowflake is a hybrid of shared disk and shared nothing architecture. So any doubts here? Okay. Now we'll see the costing part. Here we have understood like three different layers are there. So what about the costing? Yes, costing also it differs from layer to layer. It is different. I mean calculation also different and usage also different. Everything is different. Now, first we'll come to the database storage layer costing part, how it works. So here on an average per month, how much data you are storing, that much amount we have to pay. So it will be calculated in the measure of TB, terabytes. On an average per month, how many TBs you have consumed, for that much TB measurement, we have to pay the amount. So more than that, no need to pay the amount, but it will be a calculation on an average per month, how many TBs of data you maintained or you stored in the database storage layer, that charges we have to pay. So here I will show how it differs through UI only. Next, the query processing layer. So the query processing layer charges will be different it is pay per second billing. Again, this pay per second billing, it differs from size of the compute resources to, let's say if we are going for an extra small warehouse, virtual warehouse, then we are using 110 seconds, then 110 seconds into 0.016 something. If the same 110 seconds we are using L virtual warehouse, then we have to pay 110 into something like let's say 1.23. It will get doubled, right? The rate of cost. So that much we have to pay. So here again, it's a pay per second billing. How much you have consumed, only for that period you have to say. So now I am saying like for L warehouse, this is the cost. For small, this is the cost. So when I will show that in the virtual warehouse class, when we have used the small warehouse, how it differs. When we have used the L warehouse size, how it differs, we'll see in tomorrow's class. In the virtual warehouse class, I'll explain how it differs. But as of now, it's a pay per second billing. How much you have consumed, that much charges only it needs to be paid. Again, both the storage and query processing, whatever the rate I am saying, it differs from cloud to cloud. So we have three different clouds, AWS, Azure, GCP, and region to region. In the same cloud, if you are differing to region, it will differ. The rate will be different somewhat, like it may be increase or decrease, but it is not a constant across all the clouds and all the regions. So that also we need to keep in the mind. And the cloud services layer, as we are using both the database storage layer and query processing layer, cloud services layer is free of cost. No need to pay any charges for the cloud services layer. So this is the costing part of Snowflake architecture, like how we will use. So any doubts here? Okay, now we'll see the pricing, how it differs. So these will fluctuate from according to Snowflake criteria. See, it's not say today it is $3.7. For after a month also it should be same 3.7. They may increase or decrease, but whenever you want the latest price, you want to go to the official page and see the pricing details. Now let's say here we have platform called Microsoft Azure. So whatever the cloud platforms are there, so you can select, let's say I want to see for the AWS. And in AWS, you have these many regions. Let's say I'm going to US East Northern Virginia. Here, if you see the charges, whatever the standard enterprise business critical VPS. So here we have these editions, right? 4 editions, whatever we have discussed. So if for the standard edition, it will be costing $2 per credit. So here the measurement, like we know, if you want to buy any groceries, we will buy in the form of cages, or any liquid items in the form of liters. So here also the measurement is per credit. So here $2 per one usage of credit. So how the credit will be converted into seconds, tomorrow we will see in the virtual warehouse class how it will be done, we'll see. So if we are using consuming one credit, we need to pay $2. If it is the same enterprise edition, if we are going for same one credit, $3 we have to pay. Again for same one credit, $4 in the business critical. If it is VPS, like again the it will differ. It will be decided by the Snowflake company sales team only. We cannot have a fixed value, but for all these editions, the fixed value is there. So this is for computation, like whatever $2, $3, $4, it's for query processing layer. So whatever the size, again it differs. So basic things are these values. What about storage? So here we have on-demand storage, that is pay for usage month to month. So on an average per month, how much TB you are consuming, that much charges here you have to pay. So for 1 month, let's say you have stored or you have used 1 TB of data, then you have to pay $40 for a month. Let's say you have used only 0.5 TB, then you have to pay $20 only. So this is for storage alone. For the database storage layer, we have to pay these charges. And capacity storage, this is a different one. Let's say like you will encounter some upfront where processing will be done or huge data is coming. So at that time you can purchase this upfront capacity storages also, which costs like $23 per TB per month. So this is for AWS cloud, US East Northern Virginia. Let's say in the same AWS, if we go to some other country, Europe, London, so you can see the prices are differing. So in the standard itself, it is $2.7 USD dollars. Again, in the enterprise edition, it is 4 USD dollars. In the business critical, it is 5.4 USD dollar. It will differ. Now, if we go to the storage, here it is 42 USD dollars, and capacity storage, it is 24 USD dollars. Let's say if we go to the other region, so let's say any other government east one. So again, it differs. So I think here there are no enterprise and standard edition, only business critical is available. So we can see $5.60, and the storage is like these charges 68 and 39. So that means the charges both for computing and storage will be differing from region to region. So that point we understood. In the same cloud, if it differs from region to region, it will differ. So if I go to AP Mumbai, which is in India, so we can see the ranges are like this, and $46, $25. So in this way it differs. Let's say if we go to the Microsoft Azure. So again we need to be mindful here. The same region, let's say in AWS, AP Mumbai is there. The same region might be available or not. So let's say if I go to the Microsoft Azure, the regions will be differing. So here the region is East US to Virginia. The same region is not available with the AWS cloud. Maybe it is also may or may not. So if we go to the US to Virginia, we can see $2, $3, $4, and the storage is $40, 23 is capacity storage. So it will differ. Let's say same in the Microsoft Azure, you will just go to the India region. So where it is Central India, Pune. So almost $2.2, 3.3, 4.4, and capacity is 25. On demand is 46. So it will differ from in the same cloud. It will differ from the region to region. Now Google Cloud Platform. Again here the regions, very less regions are there. So you can see the difference between again region to region. So we can see the difference. So the pricing, the basic pricing, both for computation per credit per TB per month, the storage cost and compute cost will be this one. Again, based on the compute resources, whatever you have created. This is for extra small. So if you go for the small, medium, large, again it will be differing. Whatever the prices here it is showing, it is the starting prices. For the basic level of usage, these prices. If you are using more and more compute resources, again it will be charged. Charges are differing. So that we'll see in the tomorrow's class with the virtual warehouse concept. So we need to discuss like what are the modes policies. According to that, the charges also will differ. We'll see there. So any doubts in the architecture part and costing part, pricing part? Okay. Now the final thing I want to say here is like in our training module also we will have 3 environments: development, UAT, production. But in a single Snowflake account, how we will maintain 3 different environments, I will show. Whatever the practical sessions we are doing, at the time we will work in the development. Then when we are discussing about the project migration, I will show how to migrate to UAT and production environments. Next, whatever the model I am going to explain in our training. So this model, what it's exactly replica to my project explanation. So why I will do that? Because if we start here, like how we are getting the raw data from the source, how we are processing that, how we are converting into a finalized information. So the same thing, your project also will be there. So here we will create 3 different layers of databases: pre-stage, stage, DW. So pre-stage will hold all the raw data, and the stage will be like data load is there. Then we will move that to the stage layer, and finally DW layer, like it will be full, like by joining all the stage table, we will create one set of information, a fact data, and will be giving to the reporting team. So these are the 3 different Snowflake table layers. Like, I mean, the architecture layers are database storage, query processing, cloud services. These are the project data model layers of databases. So we'll explain all this with the help of this. We will complete our training. Okay. Any doubts here? Okay, guys. If you don't have anything, uh, we'll see in tomorrow's class with the new topic. Thanks, everyone. Have a nice day.
Thank you.